Finding the epicenter and magnitude of an earthquake. CPS Earth Science 2012-13. First, read the directions. The directions for this lab are in the packet that I gave you in class. They go through all the instructions that I'm about to talk about. This will be just like the example we did in class. First, we're going to find the time interval between the P wave and the S wave. Look at the seismogram. Count the seconds on the x-axis between the 0 point and the first S-wave pulse. Record your findings on the top sheet in seconds. For this example, the distance between the S and P wave was about 36 seconds. We take a look here. We start at 0, and our first pulse is here. We draw down, and right around here is 36 seconds. Using the same seismogram, we're going to now measure the magnitude of the S wave. The magnitude is going to help us with the distance that we calculate later to find the magnitude of the actual earthquake. Look at the seismogram. Count the distance on the y-axis between the 0 point and the highest peak of the S wave. You're going to record this in millimeters on your sheet. For here, the first pulse starts at about 0 and goes all the way up to about 350 millimeters. So on our top sheet, we are going to record 350 millimeters for this city. Now you're going to repeat this process. To triangulate an epicenter of an earthquake, we need at least 3 points. So that is why you're given data from 3 different seismograms from 3 different cities. By the end, you should have 3 SP wave times and 3 S wave magnitudes on your top sheet. Now we're going to make some conversions. Once we make these conversions, we're going to be able to know distance, and then we're going to find magnitude of the actual earthquake. So, taking the time intervals from our top sheet, using the time it takes for the waves to travel, we can find the distance using this chart. You start by finding the time on the x-axis for your example. Then you draw straight across to the diagonal line, and then draw straight down. Then you're going to record this value in kilometers on your top sheet. Repeat this for the 2 other locations. Now, with the amplitude of the seismogram and with the distance in kilometers, we can find the magnitude on the Richter scale for the earthquake. Using the top sheet information of distance and amplitude, we'll use the next table to find the Richter magnitude of the earthquake. Remember that the Richter scale is a measurement of energy released in the quake, and it's logarithmic, meaning that 2 is 10 times greater than a 1 on the Richter scale, and a 3 is 10 times greater than a 2. So that would mean that a 3 on the Richter scale would actually be 100 times greater. This is an open-ended scale. There is no top value, but the highest recorded earthquakes on the Richter scale so far have been about 9+. So to use this for our lab, you're going to find the epicenter distance from your top sheet on the left side and put a dot. Then you're going to find the S wave amplitude on the right side, put a dot, and then you're going to draw a line in between the 2. Now you're going to repeat this for the 2 other cities, and what should end up happening is you should end up getting a line that ends up finding you the magnitude for your earthquake. And again, if they don't cross exactly on a point, they are going to come into a range, and that's what we're looking for. Record this magnitude on your sheet. Now we're going to find the epicenter. This is the actual physical location on the surface where the earthquake occurred. The actual earthquake occurred meters to kilometers below the surface on the fault or plate boundary. Using the data from the epicenter distance, we can triangulate the epicenter, but not the focus, which is below ground. The focus is where it actually happens. So first, we're going to make sure that we are using our kilometers scale for our map and not miles. You could do this with a compass if you have it, or with a piece of string and tied to a pencil, but how we did it in class was using a ruler. And while this might be a little tedious, it can, with careful practice, be just as accurate as using a compass. So, for your first city, find the distance on your map scale in kilometers. You're going to then use this distance to trace a circle all the way around your location. So using a ruler, draw a series of dots around your city at a distance prescribed by the map key. Once you've done that, then connect the dots. And you're going to repeat this process for the 2 other cities. Where the 3 circles meet, that will be the earthquake epicenter. So for this one, I draw the dots around Fresno, then I connect them, and I get my first one. Las Vegas, draw my dots, connect it. That gives me this area is where it could possibly be, and this is why I need a third. So I take my information from Bakersfield and then draw the dots, and I find that the epicenter of the earthquake is where the 3 meet. Now you're doing 3 different cities in your homework assignment, but check the directions and re-watch this video if you need to. But you have all the things you need to complete this assignment.